Hi all, welcome to the next practical session of embedded software testing, and today we'll try to go through a session about Code Warrior in terms of creating a project and how to debug, because we know in dynamic testing we need to execute the embedded software onto the target using a equipment called IDE. So we have integrated development environment. So which is basically used for connecting the embedded target with the help of target connectors such as JTAG or any of the debugger ports, BDMs, etc. Then we have the actual target, and we have the compiler built into the Code Warrior Code IDE. Code Warrior is basically an IDE, and we'll try to understand how we can use the debugger. So basically, with the help of that, we can try to set the breakpoints, stop it, view memory, and monitor the variables, how to watch the memory, modify. So like this, there are several aspects of that. We'll try to study that in a couple of sessions. Today we'll try to go through a video of Code Warrior. Basically, we have Code Warrior connected to a microcontroller. So most of these free scale microcontrollers, they have Code Warrior used, especially in the initial series of HC08, HC12 series processors. These are popular processors since almost a couple of decades. They are using on the automotive, industrial, and such microcontroller applications. So let's try to understand how to create a project with an example demonstration. Learn how to debug the code, learn how to set the breakpoint, and how to watch the memory. So these are some of the exercises we'll try to understand, and we'll continue the exercise in the next session. Okay. So basically, these videos are all from one of the embedded expert videos called Processor Expert Software. So this series we are referring to understand. So in terms of the lab session. Okay. Okay. So this YouTube is video is from Processor Expert Software series. We'll just basically try to go through, and in the future session we'll try to understand how it works. So it is called as a kinetic processor socket. With the help of that, we will try to understand overview of the Code Warrior tool. Okay, so we'll begin with an example project workspace. So this is a window. You can see the Code Warrior project workspace where we have components, categories, Code Warrior project listed here, and in terms of managing the projects, build settings, debugging, and all that we can see here. We can see the console where debugging output will be provided. So we'll try to open an example project. So we'll click the import project, and there is a import project in some of the repository. So we have an import window. We can browse through the example project. Here we have one I2C project we have. We'll try to go through that, and we'll select that, use it. You can see the project got selected in the left hand side, where it lists the file names with the different folders. So, I am trying to build the project. What he's saying in terms of the processor expert. This is a project file. You open the P file. This is a project processor expert project file. You can see there are several options coming up in terms of configuration like flash, memory, and the components what you want to use it in the project. So you can see these are basically the registers that are part of the processor. You can see that internal oscillator, clocks, and all that. These are basically the components of the processor. What this does is the processor expert does is it will have libraries to populate those registers and ask user to select the CPU, external, internal peripherals, devices, register settings, interrupts, clocks, and all the stuff. So with the help of that, we can choose these options and build the project. Okay, so these are some of the categories that the components library that has been built in the processor expert of the code warrior, where you can see the board support, information, CPU external devices, CPU internal peripherals, logical device drivers. If the board has a connection in terms of I2C or server, then we have an operating system in terms of a small kernel or scheduler. Then we have the software or the software application configuration. So you can see in closely some of the views. So there is one OS selected as MCX Lite. Other components you can select in terms of multiple tasks, what you want to have it. So there are several tasks underneath this OS components. So we are just trying to understand how the UI works. So what components are used in the MQX OS that is built as part of the processor expert. So these are several methods within the components. If you want, you can configure it. There is one library. It is being selected here in this, and for that library, TSSI, you can see the library having the different complex components of that library can be selected or deselected or used. So basically, with the help of that, the project is built. Okay, so you can see logical device drivers in terms of communication, converter, many drivers are there from multiple peripherals of the processor. You can choose like timer, what sort of a timer you want to have. So this basically this video is for building the project. Similarly, we can use it for testing in terms of what is used after loading this project already used for development and see what configuration it is using and what is the behavior. Something like watchdog we have here, and you can see the source. We can remove if you don't want to have that component. So what processor expert does is generates the code for this and builds the project. You can click on the generate button and it will generate the whole project. Okay, so we'll try to study another project. similarly created in Code Warrior. It's a more simpler one. We'll try to study this what it does. Okay. So today, in terms of Code Warrior Development Studio, how it works. This video should help. There is a workspace. We can select it in terms of lab example path, or you can create a directory, name it, and you can store projects in that folder called a workspace. So workspace will have one or more projects will be available, but better to have a separate workspace for each project. So if there are complicated projects having multiple files and all that, so it is advisable to have one workspace. Underneath that we can have multiple projects. Similarly, you can build a test project having instrumented code, and for the unit which you are interested to feed more values, configure the code and test it. What is the behavior of that on the target? We can build the project this way. Okay. So the Code Warrior Studio editing setup. Is the first page basic thing. It's called as a perspective. It's a set of different projects settings you can see. So you can use this welcome screen to create a new project. So you can click that new project wizard, and you can name the project here for the microcontroller unit that is being specified here. You can call it as a lab one. You can press next, and you can choose what sort of a board we have. On what processor, like SES 08, call for Y1, V2, V3. So one of these processors we can select it. Coldfire V1 is being used. It is a family of all the Coldfire processors from Motorola, Freescale. So there is a processor called MCF 51CN128 that is being selected, and what sort of a connection that we have with the end target from this IDE, we can select it. So there are different options like USB based BDM debugger, or a serial port, or a TCP/IP, or any JTAG, etc. So PND USB BDM link is used here. You can have also open source BDM, which is already available on the evaluation board. So any files you want to add, you can add it here. So Coldfire build options, you can set it here. What sort of a build you want to have? You want to have C++ support. You want to enable processor macro, which helps porting code from any scaled down process, something like HCS 08 to this Coldfire. So no porting is selected here. Any input output in terms of printf statements, you want to have a console or no console. Any floating point support you need, any optimization or easier debug, etc. All these options part of the build we need to select so that the embedded software program is getting built. Okay, next we have rapid application development in terms of building the entire workspace from the project. We can select either device initialization or the IDE itself using the processor expert, what we have seen earlier, like in terms of configuring the various values of the registers, the devices and all that. Either you can ask a processor expert to initialize, or you yourself can initialize, or none of them you can use. So here it is not used processor expert. It is no this is used, no option is used on like that. Okay. Now this lab one project example, you can see different folders that got created in terms of project settings, library, including files and sources. So you can see that view of that C++ on the right hand side or top side. So you can just go ahead and select the project window. Underneath that you can build the project with build all. So it is going to build the entire project, and Control B or build all you can use. Then you are going to have create a debug configuration, how you want to debug this project after you have build or compiled the project. Okay. Here with this window you can have the debug configuration. There is a example code warrior download you wish to have. That is why this has been chosen. So basically the program what we have built is trying to get flashed onto the board. You can see that ELF format extended linker format. So got generated out of that build what we have done in earlier step. Same thing can be flashed onto the target board. And you can directly go for the debug option. It will automatically open the debug perspective here. You can see that right hand side. Now it's downloading onto the target. It is burning into the flash, and you can see the debug window showing the first window after it is loaded. And here you can see the debug the operations. So what are the things that we have done? Here you can see the file, which file it is being currently programmed or currently being executed. You can see the console in terms of input output. You can see the disassembly of that main file what you have seen the source here. So the executable code you can see just a simple code, main enable interrupts in a for loop. Some reset watchdog is getting done. This is why, because it has a watchdog circuitry, and the watchdog should be again and again satisfied so that no reset is going to happen. So any embedded software, you know that it should be called in a while one or for one loop. While one is preferred. However, in this example you can see a for loop. So this is the project, and you can see you can click the resume option. You can use. Now the program is running on the board. You can pause it. It will show where it is stopped and where it is running. You can see the assembly as well as the source where the project is being executed. So it is continuously running around the for loop. You can resume it. You can stop or terminate the project execution. You can disconnect the target which is connected to this IDE debugger environment. What happens when you disconnect is because you have flashed, and in earlier option you said that you resume or execute. So though you have disconnected, actually you have flashed the program and asking it to run independently. It will keep on running on the target, but the BDM or the target that is being connected will will not have any debug option available. So here we have the IDE. Here we have that BDM debugger module, and actual target is here. So what we try to do here with this IDE, we try to load the example program, and we have flashed onto the flash circuitry of the target board, and we said let it run, and we disconnected the target. Still the target board is running. Similarly, we can connect it back and start executing it. Okay, so now we can see the source code C++ view where the original source is being displayed. If you want, you can add a code. For example, let's see. There is a code getting added. There is a variable called counter is added here, and in the for loop, there is a counter that is getting implemented in the for loop. So you save it with Control S. Then since you have changed the source, you need to rebuild the workspace. So it will be rebuilt. So you have the debug connection setup. Then you can switch over to the debugger. You can see that it is getting downloaded onto the debugger and the target. This is the progress it shows. Once it is done, as it was showing earlier for us with the new code, you can see that new code is getting displayed here, and the disassembly of the same will be shown here, and you can see that debugger showing this latest program. Okay. Now this window shows the different stack trace in terms of what has been called first, second what has been called, like a call trace it is showing. So you can see that what is being used. If you click that startup, that is what before main is getting called, the basic startup is being used, and the assembly of that is being used. Usually the startup routine is written in assembly. All that basic work in terms of processor installation, cache, translation, look ahead buffer, flash to RAM copy, all that instructions will be there part of the startup in any embedded software before the main is actually getting called or executed. You can see that there is a main it has come, so there is a execution of this. There is a counter you can see which we have used. It's called a global variable. Some value is being displayed since we are continuously pre-implementing it in every cycle. So there are about 3 lakh values that got updated, and also you can see the memory where this counter is lying on the target. We can run again this project. You can see the counter getting updated or implemented. You can also see by moving the cursor on the particular variable of the control. You can also hover it over that declaration as well. You can see the values of that, what is being shown. That's how we can see the values of the variables and do the debugging. So now we can try to set a breakpoint, simpler one, and try to see what's going on in each cycle. You have to double click here. This is a pane where pane pane where you can click and see that breakpoint is being enabled, and when you execute it's going to stop at the breakpoint. You can see every run it's being clicked here and it's going to stop because we have set the breakpoint. Every time the breakpoint is hit, you can see the counter is getting implemented, right? So if you remove the breakpoint by double clicking and run it, and you can go to the breakpoint window, you can disable it with this option and run. It will run a free execution, and while doing the execution or when you have stopped it, you can modify the value in memory or the location what you have seen. This will be useful for testing how the behavior of the program to ensure that different aspects of the project variables, how it is getting used and synced. So that's what the example shows. You can have a breakpoint in different places like this. Some of the embedded systems will allow maximum 3 hardware breakpoints and unlimited software breakpoints. Here hardware breakpoint means the breakpoints that are getting loaded from the target directly when the target is executed with the actual target memory in the flash, which is mapped to the execution program of the RAM. So you see that value being changed from something to 0, so that the new variable value is being loaded, that 0 is being loaded. You can create a watch point, toggle watch point, you can click it here, and the counter we want to have a watch, and breakpoint is enabled here, and the properties condition we can put for the watch point. The counter when it reaches 10, we should be able to stop and see the watch point. It's 0 now, so we are going to resume it, and in a moment it's going to show the value of 10 and it has hit, right. We can set it back to 0 and execute continuously. It will be incremented continuously and it stops at 10. You can take it out again and try to now we can see the variable is getting updated with so this is what the basic debugging aspects of the Code Warrior, one of the popular debugger that is being used in the industry. Okay, so in the next session we will try to understand the next type of Code Warrior debugging for different process settings. Okay, so in the next video we will try to understand another type of project creation, and here same Code Warrior with a different version is being tried to create new project, and let's try to see the different options. Like you can create a new project, you can load the existing project, load previous project, and then getting started. Some tutorials are also there with examples. Okay, so we will try to create a new project. Click on that new project. Here you can see this Code Warrior supporting this sort of a processor family like SC08, HC08, RS08, Qualifier. These are basically different microcontrollers we can choose. It will give a basic information about that processor in this and the connections that are used. So we can have multiple connections for different processors. Okay, one of the SC08 we'll try to select. We can see in the video. So the processor that got selected is MC68HC908AP16. So in this we can have a connection something like emulator or PND multi-link or mono 08 interface or full chip simulation, where simulation is done without the target connection. End of this processor, if you select, same option will be there. Then we can have languages what you want to have like this project to be created, like in C, C++, assembly or relocated assembly from different platform. So C is being selected here. The project name, it usually microcontroller project under Freescale will be .mcp. You select the folder. So C is selected here. If you want absolute assembly where pure assembly is used for the entire project, you can select that. In this example, the example assembly project, let's try to see, because embedded software will also have assembly code, so you may need to test it. So in order to do that, we need to understand how the assembly code is being organized into the embedded project. So there is some LED project that is being created here. So any files that you want to have added, you can add it in that folder. So any rapid application development option you want, or device initialization you want to have your own, or project processor expert you want to select. For assembly it is not there, that option, so none is selected here. So now the project is being created. You can see here the source main.asm project libraries and all being displayed here. So this is a debugger window on the left hand side where all different debug options are available. So you double click on that main.assembly, you can see on the right hand side there is a assembly that is being displayed. So it includes two libraries, I.INC included library. There is another process specific library also there. You can see that. Try to see all the microcontroller related memory map, interrupt vectors, and all that are defined here in this library. We can use any of these variables in order to set that values. Let's see what's going to be used. Okay. Now main.c, you can see main.c. You can see that main.c being used, and main.c includes the other library included. As usual, we have in a C similar to that. Okay. You can see the assembly and disassembly. On left hand side, you can see the actual source, and you can see that CPU cycles, how much it is being used, stack pointer, accumulator, status registers, status of that particular microcontroller being displayed here, and you can see the memory that is being used. Each memory address is 16-bit. That specific memory addresses with that MSB first and LSB last being displayed here, and we can have a continuation of that single step you want to have. You can have step out, step in, halt, and final execution on the target. We can do. You can do the reset here. The single step we can do. You can see step by step the lines have been executed. You can set the breakpoint, modify any of these values for any testing that you want to have, and run it. So assembly project is being used in the code warrior. You can see the breakpoints if you want to set for a particular line. You can set it and watch the accumulator what value is coming. Especially this assembly debugging is useful when you want to have a boot software embedded testing related things where different registers you want to verify with the right click options. You can set the breakpoint and watch window. You can see that run till cursor. You can have that with that value modified and see the behavior of the CPU, what is going to happen. So basically load, store, set sort of instructions will be there, and the stack pointer has FF that is loaded in the memory. So let's try to understand. Let's try to understand the next type of a project, how that is being debugged and used. This is a K20 family project is being processor family is being used, particularly K and K20 and 28. So it depends on the development weight, whatever you have, that particular processor needs to be selected. You can see there's several options like we have seen last time. The PND USB multi-link universal connection is being used. If you want to use the onboard JTAG, want to use open source, you can use. Here it is being used. So you can select any of these languages. Here in this project, device initialization is being used. You want to add any files into the project, you can search with this click option. You want to copy that files into the project, you can use this option. You want to create a main.c operation, you can select that. So the environment is being created here. You can see that target CPU project K20 bareboard. So under sources you can see there is a couple of C files and there is a header. There is a installation code generated automatically. You can see the MCU unit.c and the header file being generated by the tool itself. So we should not modify this basically. Main.c, you can see this is a library studio used. There is a simple counter similarly what we have seen earlier being used here. You can build with this hammer option. There's a drop down in terms of internal flash you want to do or internal RAM. You know the difference, like flash is the permanent storage, RAM is the one that is going to when it is power up. We can yes, the selection is RAM here, and it's being run and debug here with this option. Code warrior connect or download, you can select one of the options and debug it. So it will switch to the debug perspective here. And you can see the multiple windows like what we have seen earlier in terms of the trace and source and the assembly. So there's a target that is being plugged in here and it is ready to start here. We say you can see there's a breakpoint being set here. This counter the breakpoint is being used here. This is being run now. There are stepping commands like step in, step out, step return from the function. You can see there is a breakpoint counter plus the project has stopped here. Counter value you can see it here. Again you run it here. You can see that counter value is implemented because continuously it is getting called by the program. This is a Code Warrior 10.2 version that is being used. Okay, so this is how we can use the debugger in terms of loading the project, reusing the project, modifying, adding the files, setting the breakpoint, making the changes into the counter or any variable and watched in the memory. Likewise, we can have it and we can scale it up for complex projects this way. Okay, so we'll continue in the next session in terms of more exercises. And till then, see you. Thank you. Bye bye.